Hello students, in this video we will start the very important topic, that is electric field intensity due to infinite length line charge. So here we are selecting the cylindrical coordinate system in which we have to derive the expression. Then we have taken infinite length line charge as a z-axis. Now on this z-axis there are charges present, in which rho L is the line charge density. Then we are taking very small section here as we discussed. Then the charge on this small section dq is equal to rho L into dl, and the coordinates of this point is 0, phi, z. We are taking from the bottom height z, and rho is equal to 0 because it is on the z-axis. Now this is the point B where we have to calculate the electrical intensity. Here is the point. Now we are joining this small section to this point, and this distance will be under root of rho square plus z square. Rho is the perpendicular distance from the line charge, and the coordinates of this point where we have to calculate the electric field intensity is rho phi 0. Now the distance square r square, it is equal to rho square plus z square, and the vector ar vector we define final minus initial divided by magnitude. Final points and final coordinates are rho phi 0 because here we have to calculate the electric field, and the initial location is 0 phi z. So rho minus 0 arrow plus phi minus phi will cancel, plus 0 minus z az divided by under root rho square plus z square. This is our arrow vector. So electric field due to small length charge dl, it is kq by r square ar vector. K is 1 by 4 pi epsilon, q is rho L dz upon r square is rho square plus z square, and ar vector is rho arrow minus z az divided by under root rho square plus z square. So dE vector, it means the electric field due to small length charge dl. So dE vector is rho L dz upon 4 pi epsilon rho square plus z square to the power of 3 by 2, because here it is under root and here it is 1 power, so total power is 3 by 2 rho arrow minus z as it. When we will calculate the total electric field, then this expression we have to integrate. We have to integrate this expression to calculate the total electric field. So the total electric field is integration of this expression. Now due to symmetry, z component will cancel because the section which is above z height from the bottom, and also this section will be below the z height from the bottom. And when we resolve the component, then from the figure it is clear that vertical component will cancel each other. And only horizontal component will present. So from vertical component, z component will cancel each other. So here we will discard these z components. So total electric field, it is equal to the rho L dz integration rho L dz upon 4 pi epsilon rho square plus z square to the power of 3 by 2, only rho arrow, and z component will cancel. And what is the limit of z? And the z limit will vary from minus infinity to plus infinity, minus infinity to plus infinity. So rho L, whatever is the constant, we will take it outside from the integration. So rho L upon 4 pi epsilon arrow, we will take it outside. Integration minus infinity to infinity rho dz upon rho square plus z square to the power of 3 by 2. To solve this integration, we will put z is equal to here rho tan theta. So dz will be equal to rho sec square theta d theta. We are putting z is equal to rho tan theta. And when z is equal to minus infinity, then theta will be equal to minus 90 degree. And when z is equal to plus infinity, then theta is equal to plus 90 degree. So this answer is E is equal to rho L upon 4 pi epsilon A rho minus 90 degree to plus 90 degree. Rho into dz, dz is rho sec square theta d theta upon rho square plus rho square tan square theta to the power of 3 by 2. Now electric field is equal to, so E is equal to rho L upon 4 pi epsilon A rho, and the limit is minus 90 degree to plus 90 degree. Rho square sec square theta d theta divided by, we will take rho cube common, and 1 plus tan square theta will be sec square theta, and its power is 3 by 2. So rho L upon 4 pi epsilon, and this rho square and this rho cube will cancel, and only rho will present here, a rho vector, and this square and this cancel, so sec cube will present here. Sec square by sec cube is 1 upon sec, and 1 upon sec will be equal to cos theta, and the integration of cos theta is sin theta. So rho L upon 4 pi epsilon rho sin theta minus 90 degree to plus 90 degree. So the final answer is the sin 90 minus sin of minus 90, it is 2. So rho L upon 4 pi epsilon rho into 2, and this 2 and this 4 will cancel each other. So electric field will be equal to rho L upon 2 pi epsilon rho A rho. So this is very important expression, right? The electric field due to line charge, and the answer is rho L upon 2 pi epsilon rho A rho vector. Thank you for watching the video, students. Thank you.